Okay folks, the last question on the paper deals with some trigonometry again. Now let's see how we answer these. They say, given this relationship is A over B, prove that the sine of alpha can be written as that. Now if you compare the two things, what's different here? The sine of alpha is by itself. This is not the sine of alpha plus 3. It's the sine of alpha plus 3. There's no bracket there. So the quickest way to kill this one is to cross multiply. Let's see. I get B sine alpha plus 3b is equal to A sine alpha minus 3a. I now need to collect my sine alphas to one side. So if I do that, I get B sine alpha minus A sine alpha is equal to minus 3a minus 3b. If I remove my sine of alpha, I'm left with B minus A. So let me just put a point and multiply it by that, is equal to minus 3 times A minus 3 times B. I'm going to continue over there. The last thing for me to do is to say that the sine of alpha, now I'm going to peep at my answer. My answer has 3a plus 3b, not these double negatives. So if I remove the negatives, I get 3a plus 3b divided by b minus a, because I'm going to divide that to the other side. If I divide the negative in, or multiply the negative in there, I get 3a plus 3b, just means those two change around, and then I have exactly what I wanted. Quite easy. The next part is saying, you know what, determine alpha if this thing is now equal to that. Now what did we just show? We just showed that the sine of alpha is that over there, 3a plus 3b. Now I'm deliberately, I should have left that open, over a minus b. So I'm going to do that because I put the b there. I was a bit lazy there. They told me that this is indeed, this is what I just proved, and I now know that this is equal to minus 12 over 13. So what does that mean? Well, if I look at the original, this thing was equal to a over b. So a is 12, a minus 12 rather, and b is 13. Okay, so a here is minus 12 and b is 13. So I go in there. Minus 12 gives me minus 36. 3 times b is 39, divided by minus 12 minus 13. So that leaves me with an ugly number, 3 over 25, which is a negative number, because this is negative. Okay, how did I see that again? Well, right at the beginning, they gave me that relationship. Now they tell me that relationship is minus 12 over 13. So A has to be minus 12 and B has to be 13. Now look at where I'm solving. I'm solving in the third quadrant. The angle I'm looking at is over there. Okay, so let me find that angle. Alpha will be the inverse sine of minus 3 over 25. Now let's put that into our calculator and see where that takes us. It is the inverse sine is second function sine of my fraction. Let me go back one. The fraction is 3 over negative 25. Now close my bracket. I get minus 6,89. So alpha in this case, I have to add, my alpha rather becomes minus 6,89 degrees. That is if I use just my rule inverse sine to get to the angle. Okay, now that would mean something for me. That would mean that my alphas either, remember, sine is negative in the third or in the fourth quadrant. Okay, so this is the fourth quadrant angle that I'm looking at. Or alpha can be 180 minus that minus 6,89 per definition. So that means that this is going to become a plus. So I times it with minus 1, I get that, and I add 180 to get to my final alpha, which is 186,9 degrees in the third quadrant. Now what did I do from there to get to here? Remember, your definition says if the sine of theta is equal to k, and clearly that k lies between minus 1 and 1, which is what it does here, then theta will be twofold. It will be the inverse sine of k, or 180 degrees, minus the inverse sine of k, and then plus multiples of the period for sine. That's the only thing I did here. I applied my definition. I didn't make it a general solution because it's over that domain. Okay, and that's my final question, question 12. I hope that that made sense to you folks.